Hello students, this is the next lecture for paper 2 Business Statistics second paper for TY BCom students. Second term unit 6 lecture 1. Name of the topic is Test of Hypothesis 1. Lecture 69 TY BCom unit 6 Business Statistics second paper Test of Hypothesis 1. There are 18 lectures allocated to this topic. See the syllabus. Definitions of hypothesis, null hypothesis, alternative hypothesis, critical region, types of errors, level of significance, p-value. Test for population mean for large and exact sample. Describe test procedure for testing. First test H0 mu is equal to mu naught against H1 mu not equal to mu naught, and second test H0 mu1 is equal to mu2 against H1 mu1 not equal to mu2 if population variance is known. Then third point, test for population mean. Describe test procedure for testing. First test H0 mu is equal to mu naught against H1 mu not equal to mu naught, and second test H0 mu1 is equal to mu2 against H1 mu1 not equal to mu2 if population variance is unknown. Fourth point, describe the test procedure for parity test. Fifth point, test for population proportion. Describe test procedures for testing. First test H0 p is equal to p naught against H1 p not equal to p naught, and second test H0 p1 is equal to p2 against H1 p1 not equal to p2. Introduction. In order to study a group of large number of items or individuals, we require to draw sample. We use the technique of sampling several times in everyday life. Thus, sampling is well accepted means of collecting information. Moreover, it is believed to be scientific and objective procedure. Sampling plays very important role in statistics, statistical inference. Hence, we will define the terms like population and sample. Definitions. First definition, population. An aggregate of objects or individuals under study having some common characteristic is called population. Sample. Any part of population selected according to statistical rule to study the population is called a sample. Next definition, parameter. Parameter is a statistical measure based on the units of a population. The parameter of the population could be population mean, population variance, correlation coefficient, etc. Next definition, statistic. Statistics is a statistical measure based only on all the observations selected in the sample independent of population parameter. Testing of hypothesis. Quite often we need to test some claims regarding populations on the basis of sample. For example, first example, a particular scooter gives average of 50 km per liter. Second example, proportion of unemployed persons is same in two different states. Thus, mainly we are interested in testing certain claims. So next is definition of hypothesis. It is a statement or claim or assertion about the statistical distribution or parameter of statistical distribution. In other words, hypothesis is an assumption to be tested. For example, average life of bulb is 1000 hours. It can be written as H0 mu is equal to 1000, where mu represents population mean. Second example, proportion of batteries in certain locality, a proportion of literates in certain locality is 55%, can be written as using population parameter proportion as H naught P is equal to 0.55. There are two types of hypothesis in every problem of test of significance. If one is rejected, the other is to be accepted, and vice versa. These hypotheses are referred to as null hypothesis and alternative hypothesis. Null hypothesis. A hypothesis of no difference is called as null hypothesis, or null hypothesis is the hypothesis which is tested for possible rejection under the assumption that it is true. Null hypothesis is denoted by H naught. Alternative hypothesis. A complementary hypothesis to null hypothesis is called as alternative hypothesis. In other words, it is hypothesis to be accepted in case null hypothesis is rejected. Then type 1 and type 2 errors. Since decision of acceptance or rejection of H naught is based on sampling, it is subject to two kinds of errors. For instance, in the inspection of lot of manufactured items, the inspector will choose a sample of suitable size and accordingly take decision whether to accept or reject a lot. In this process, two errors are possible, that is, rejection of a good lot and acceptance of a bad lot. In testing of hypothesis, these errors are called as type 1 and type 2 errors. So type 1 error, rejecting H naught when it is true. Type 2 error, accepting H naught when it is false. Actual situation, H naught is true. Decision, reject H naught. Then this becomes type 1 error. Actual situation, H naught is true and decision is we are accepting H naught. Then there is no error, so decision is correct decision. Actual situation, H naught is false and we are rejecting it. Then it is also correct decision. Actual situation, H naught is false and we are accepting it. Then it is called as type 2 error. Critical region. Let x1, x2 up to xn be a random sample taken for testing H naught. While deciding whether H naught is true or false, entire sample space is divided into two non-overlapping regions. One of the regions is acceptance region of H naught and the other is rejection region of H naught. A region in which H naught is rejected is stated as critical region. Test of hypothesis. It is nothing but a rule which leads to the decision of acceptance of H naught or rejection of H naught is called a test. Test statistic. A function of sample observations which is used to test H naught is called as test statistic. Next definition, level of significance. A probability of rejecting H naught when it is true is called as level of significance. It is denoted by alpha. P-value, it is also called as observed level of significance. Instead of fixing the level of significance uniformly same for all data sets, sometimes it is computed for the data set used in testing of hypothesis. P-value is the smallest level of significance at which H naught would be rejected. The next concept is large sample tests. Practically, samples may be regarded as large if the sample size n is greater than 30. In this case, the common thing is that the distribution of underlying test statistic is taken as standard normal variate. So, tests of hypothesis are divided in large sample test in two parts, large sample tests and small sample test. Generally, for n greater than or equal to 30, the large sample tests are applicable. The procedure for carrying out this test involves the following steps. First step, set null hypothesis H0 and the alternative hypothesis H1. Second step, choose appropriate test statistic Z. Third point, compute numerical value of Z for given sample. Fourth point, compare Z with the critical value of Z, that is Z alpha by 2, as given in the table below. So level of significance alpha is 10%, then critical value is 1.64. If level of significance alpha is equal to 5%, the critical value is 1.96, and if level of significance alpha is 1%, then the critical level is 2.58. So if mod Z is greater than or equal to Z alpha by 2, we take decision to reject H0 at level of significance alpha. Fifth step, state the conclusion about the claim made in the problem. Now we will see testing. First large sample test. The name of the test is testing population mean mu equal to specified value mu naught. So let x1, x2 up to xn with a sample observation in a random sample of size n, large, from the population of x with mean mu and variance sigma square known. On the basis of this sample, we wish to test whether the population mean is mu naught, some specified value. The test procedure is as follows. Step 1. H0 is stated in terms of notation. Mu is equal to mu naught against H1, mu not equal to mu naught. Step 2. The level of significance is alpha. Step 3. We know that x bar follows normal distribution with mean mu and variance sigma square upon n. The test statistic Z is given by Z is equal to x bar minus mu naught upon sigma upon root n will follow normal 0, 1. Critical region in this case is Z, mod Z greater than or equal to 1.96 at 5% level of significance, mod Z greater than or equal to 2.58 at 1% level of significance. If calculated value of Z is more than 1.96 or less than minus 1.96, H0 is rejected and accepted otherwise. So H0 is rejected at 1% level of significance if calculated value of Z is more than 2.58 or less than minus 2.58. See the example based on this concept. Illustrative example. An automatic machine is designed to fill tins with 2 kilograms of oil with a standard deviation of 0.1 kilogram. A sample of 100 tins was examined and the average weight was found to be 1.94 kilogram. Can we say that the machine is working properly? So first step we will write H0 in notation. H0 mu is equal to mu naught versus H1 mu not equal to mu naught. Next step is to write H0 in words. The average weight of the tin may be 2 kg. Under H0, the test statistic is given by Z is equal to x bar minus mu naught upon sigma upon root n, where x bar is sample mean, mu naught is claimed mean, sigma is population standard deviation, and n is sample size. Given that x bar is 1.94, mu naught is 2 kg, sigma is 0.1 kg, and n is 100. So Z is equal to, this is the formula, this is the test statistics we are writing again. Z is equal to x bar minus mu naught upon sigma upon root n is equal to 1.94 minus 2 divided by 0.1 divided by root of 100. So that is nothing but minus 0.06 divided by 0.01. So answer is coming minus 6 is the answer. So mod Z calculated is equal to mod minus 6, that can be written as positive 6, which is greater than 1.96, Hence, we reject H naught at 5% level of significance. We test at 1% level of significance. So mod Z calculated, which is nothing but mod of minus 6 is equal to 6, is also greater than 2.58. Therefore, H naught is rejected at 1% level of significance. So we can conclude that conclusion is machine may not be working properly. See the next example. The mean diastolic blood pressure for a group of 81 adults was found to be 79.2 mm. Test the hypothesis that the mean diastolic blood pressure is 75 mm. Population standard deviation is known to be 9 mm. See the solution. First step is always to write the hypothesis in notation. Mu is equal to mu naught. Against H1 is mu not equal to mu naught. Then next step is to write H naught in words. The mean diastolic blood pressure may be 75 mm. Third step, under H naught, the test statistic is given by Z is equal to x bar minus mu naught upon sigma upon root n, where x bar is nothing but sample mean, mu naught is equal to claimed mean, sigma is population standard deviation, and n is sample size. Now see the problem statement. The mean diastolic blood pressure for a group of 81 adults, so value of n is 81, was found to be 79.2 mm. So actual whatever value we are getting, that is nothing but x bar. So value of x bar is 79.2. Test the hypothesis that the mean diastolic blood pressure is 75 mm. So they are claiming for 75. So that is nothing but mu naught. Population standard deviation is known to be 9 mm. So we can say that x bar is 79.2, mu naught is 75, sigma is 9, and n is equal to 81, because group of 81 adults. So that are the given values. So given that x bar is equal to 79.2, mu naught is equal to 75, population standard deviation is 9, and sample size is 81. So these are the given things. We'll replace all the values in the formula. That is, test statistic Z is given by x bar minus mu naught upon sigma upon root n, which is equal to 79.2 minus 75 divided by 9 upon root of 81. So we can say this is equal to 4.2 upon 9 upon 9, that is equal to 1. So which is equal to 4.2. So mod Z calculated is equal to mod of 4.2, which is nothing but 4.2. We will compare the calculated value of Z with 1.96. So 4.2 is greater than 1.96. Therefore, we reject H naught at 5% level of significance. Then mod Z calculated is equal to mod of 4.2 is equal to 4.2, which is greater than 2.58. Therefore, we reject H naught at 1% level of significance. So the conclusion is that the mean diastolic blood pressure may not be 75 mm.